All right, IBSL1. Today we're going to do our best to wrap up Chapter 3. We're going to talk about discriminants and the applications of quadratics in general. So, last class we sang a little song and we learned about the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. Now, what we didn't talk about is this little part that's just underneath the square root has a special name. That name is the discriminant. So the discriminant is the b squared minus 4ac part of the function, or of the quadratic formula. Now, there's some properties of the discriminant that can help you realize how many solutions to your equation can have, or like connecting it to graphs, how many x-intercepts you guys have. So, if b squared minus 4ac is greater than 0, meaning that it's positive, so we're looking at this right here. If b squared minus 4ac is greater than or equal to 0, then the equation ax squared plus bx plus c has two real roots. Oh, two distinct real roots. Sorry, they're different numbers, my bad. Two distinct real roots. Well, we'll just fix it. Don't worry, we got it. Real, there we go. Two distinct real roots. Now, on a graph, the way that roots show up on a graph is x-intercepts. So that's going to be two x-intercepts. Once again, two distinct x-intercepts, so different numbers. If your b squared minus 4ac is perfectly 0, this does happen sometimes where it's just a 0 underneath that radical sign, underneath the square root, then this means you have two equal real roots, but it's really a repeated root. So two equal roots. So really I'm just going to say it's one repeated root. So that's where it's kind of, well, on a graph, it would be just one x-intercept. And I'll draw some pictures of this for you in a second. One x-intercept. If your b squared minus 4ac is less than 0, then this means you have no real roots. Now, less than 0 is a negative number, so if you picture a negative number inside the square root, that would mean imaginary numbers. But once again, this level of IB doesn't care about imaginary numbers, so we're not going to say it's two imaginary roots or something like that. We're just going to say they're not real. There's no real roots. And no real roots would mean no x-intercepts, which means it does not touch the x-axis. Just a quick visual on that. If your discriminant is positive, that means that it would touch at two spots on a graph. It would have two distinct real roots, so it would look something like this. Now, I'm drawing a parabola that's like turned upside down, but it could be right side up, but we do know for sure there are two spots where it touches the x-axis. If it is negative, it means that there's no real roots. So here, if the discriminant, b squared minus 4ac is negative, that would mean something like this, that it comes down and then it does not touch the x-axis. So notice, does not touch here. No real roots, no x-intercepts. If the discriminant is perfectly 0, which that does happen from time to time, it will come down and touch in one spot. Let's see. Yeah, perfect. It comes down and just barely touches the graph in one spot like that. Now, it could be upside down. It could look something like this. That would be the same thing. Barely touches in one spot. Just like you could have a version of an upside down one that doesn't touch the x-intercept here. Or you could have another one that goes like, something like this. But yeah, I'm just giving you guys possible examples of these pictures. Okay, some examples. Find the value of discriminant and then state the number and nature of the roots. So, discriminant, once again, is b squared minus 4ac. So if I'm going to find the discriminant of this would be 5 squared, that's the b, minus 4 times a times c. So we get 25 plus 8, which is what, 33? Which is a positive number. So because it's positive, that means that there are 2 distinct real roots. Jeez, it's just a train wreck. Let's do a box. Oh my gosh, why is it skipping like that? Sorry, guys. So, because the discriminant was positive, that means there's 2 distinct real roots. Now, this second example, we got to do a little bit of rearranging. We got to get the 25 to the other side, so add 25 to both sides. Then, when we do our b squared minus 4ac, we'll get 10 squared minus 4 times 1 times 25, which is a hundo. Take away another hundo? Oh my gosh, it's perfectly 0, you guys. So the discriminant is 0, which if you go back up to that table we just did, that means there is 1 real root. Oh no, we're just talking about the roots. So 2 equal real roots. Another way to say this is that it's a repeated root. Yep, a circle. That's what I was going for. Cool. This next example is find the values for k, which the graph y equals x squared plus 9x plus k has 2 distinct real roots. Well, if there's 2 distinct real roots, you know that the discriminant has to be positive. Has to be greater than 0. So we're going to do b squared minus 4ac. We know this has to be bigger than 0. We have to solve this. So here we get 81 minus 4k is greater than 0. Subtract 81 from both sides, so we get negative 4k is greater than negative 81. Now we need to divide both sides by negative 4. But do not forget, anytime you divide by a negative with an alligator, we covered this earlier this year, you have to flip the alligator. So you got to change this to k is less than 81/4. And that is your answer. Any number where k is less than 81/4 will produce a parabola with 2 distinct real roots, 2 x-intercepts. Now we're going to knock out a couple word problems. A rancher wants to use 120 meters of fencing to build a pen with an area of 800 meters squared. So first up, we have to use a total of 120 meters and the area has to be 8 hundo. Now, find the dimensions of the pen. If we think about the dimensions of the pen, we have to use 120 for all 4 sides. Now, if we're using 120 for all 4 sides, because this side is the same as this side and this side is the same as this one, just 2 of the sides are going to evenly split the 120. So each 2 sides are going to add up to 60. If we say this side is x, then the leftover is going to be 60, take away the x. So these are the length and width of the pen. X and 60x, 60 minus x. If I multiply those together, length times width, that will give me the area of the pen, But they told us that the area of the pen needs to be 800 meters squared. So we are going to set that equal to 800. Now we need to try to solve this. So what we do is distribute the x, this x, to both of these terms. So we get 60x minus x squared is equal to 800. Now, to be able to solve a quadratic, I want to get everything on the same side. So I'm going to push everything to the right and say that 0 is equal to x squared minus 60x plus 800. Now, if I'm being asked to factor that, I need to find two numbers that multiply to 800 and add to negative 60. So that's where you would pull your calculator out and you would start dividing 800 by things. Here, I'll do it right now. 800 divided by 10. Nope, that's 10 and 80, which would be negative 90, because they both need to be negative to get a positive. So we'll do 800 divided by 40. Oh, I got it. It's negative 40 and negative 20. Those add to negative 60 and multiply to 800. So we can break it down into our parentheses of x minus 40, x minus 20. So when you use the zero product property and solve, you get x is equal to 40 and 20. Now, we need to find the dimensions of the pen, and we got two different answers. But if you picture putting a 40 here, like if this side is 40, then this side is going to be 60, take away 40, which is 20. Then the other answer is if you put a 20 in for x. So if you put a 20 here, you get 60, take away 20, which is 40 again. So no matter what, it's going to be 40 by 20. I don't want you guys to think that these are the dimensions of the pen right here, because that's not true. That's just the two possible values of x. So you need to check both of them in the pen equation or the pen diagram, but they do happen to be the same when you plug them in. So we're going to say the pen needs to be 40 meters by 20 meters. That part's done. Now, part B says, just using the 120 meters of fencing, what is the maximum area? So if I write a little fence equation for this, like fence of x, or no, I guess it's area. I shouldn't use f. We're finding the area of the pen. So we say area of x is x times 60 minus x. So if you multiply that out, you get 60x minus x squared, which is in standard or general form, negative x squared plus 60x. Now, if you're just given this equation right here and asked to find the maximum, maximums happen at the vertex. So to find the vertex of this general form, we're going to say A is equal to negative 1, B is equal to 60, and C is equal to 0. Then I'm going to use the x equals negative b over 2a trick. So it's negative 60 over 2 times negative 1, which is 30. So if you plug that back in, that would mean a 30 meter by 30 meter pen. So it's 30 by 30. And if you multiply the area of that, the 30 by 30 meter pen will give you a 900 meter squared pen. And that's the biggest it will get. That's that. Oh boy, look at all that. So a bakery sells pies for $12 each and with an average of 40 pies per day. Let's just highlight some info here. Pies are costing us $12. They sell 40 pies a day when they charge 12. For every 50-cent increase in price, they will sell one less pie per day. Let X equal the number of 50-cent increases. Gosh, I'm just highlighting everything. Okay, so that makes sense. If you charge more for a pie, people are going to be, buy less of them per day. So you got to find that sweet spot where people are buying like the most amount of pies that give you the most money, which is where this problem is heading. So first up, we are going to write an expression for P, the cost of a pie, after X increases of 50 cents. Well, they are starting at $12. So the price is $12, and then every 50-cent increase is going to be a 0.5x increase. So the price is 12 plus however many 50 cents you're tacking on. Part B, write down the number of apple pies sold per day in terms of X. So the number of pies sold, well, they're doing 40 pies a day, but then for every 50-cent increase, they're going to lose one. So they start at 40, and then X represents the number of 50-cent increases, so we're just going to subtract X off that. So it's 40, take away however many times you increased it. Part C says find a revenue function, R of X. Revenue is just like how much money you're bringing in before you take out costs and things like that, paying for your flour and your apples and your employees and healthcare and things like that. So we'll say R of X is just going to be the cost of each pie multiplied by how many you're doing. So the cost is 12 plus 0.5x, and the number of pies is 40 take away x. Use the revenue function to find a pie price that maximizes revenue. Okay, we have a model, and we need to figure out where the cost is going to be, maximizes. So where the revenue is going to be maximized. So the maximization is just the vertex. There's two ways we could go on this problem. We could FOIL this out into general form and then use the negative b over 2a trick. Although I'm kind of feeling like it's basically in factored form. So let's just rearrange it. And yeah, we've done this. So let's put it into a little bit more proper factored form. Here, we'll start with this. 0.5x plus 12, and then negative x plus 40. So, factored form, you got to get that a value out in front. So, you can factor out a 1/2 from the first set of parentheses, and then you get x plus 24. Remember, you're distributing the 1/2 to here and here to get this. So pull the 1/2 out to the front, and you get x plus 24 in the first parentheses. Now the second parentheses has got a negative in it attached to the x, and you need to get that guy out of there. So I'm going to pull the negative out to the front with the proper pen tool there. So that's a negative 1/2. Here, let me fix this a little bit. There we go. Negative 1/2, but then you'll be left with x minus 40 here. So the x-intercepts are negative 24, 0, and 40, 0. To find the vertex, given the x-intercepts, the axis of symmetry is going to be the average of the x-intercepts, which negative 24 plus 40 divided by 2 is 8. Now, I just found x, which is the number, all we have to do is find the pie price. So that means we need 8 50-cent increases to find our maximum. So if you take the cost of the pie, which is $12, and then we're going to add on 8 50-cent increases, That equals $16. So $16 pie price, if you put that back into the equations, I'll make a little separation here. R of 8 is going to be 0.5 times 8 plus 12, and then negative 8 plus 40. If you work that out, R of 8, I believe, is $512. So if they're selling $16 pies, they're going to sell 32 of them in a day. They're going to get maximum revenue of $512. Yep.